Okay, so let's try the limit as x approaches 0 of the square root of 2 plus x minus the square root of 2 all over x. What happens if we substitute in 0?
I don't know.
Let's try.
I'm sorry.
All right. If we substitute in 0, we get square root of 2 minus square root of 2 over 0. So we get, what's that called? Indeterminate form, right? So that means that there's probably a hole there, but possibly a jump. If there's a hole, we can algebraically do something to it, clean it up, and remove the hole so that we can actually see what the limit is. So let's take a look. We have this guy, which is a binomial over this guy. And we learned back in algebra that we could rationalize things by multiplying through by the conjugate. And even though we don't have the square root in the denominator, we can still use that technique to help us simplify this function. Now, before we even start, what needs to cancel? You need to know going in what you're headed for.
The x's?
The x needs to cancel because x minus 0 is what's causing the hole, right?
Correct.
So we need to cancel an x. So keep that in mind. So we're going to multiply top and bottom through by the conjugate of the top. And here's a little tip. When you're in here, when you're cleaning things up and you're multiplying by conjugates, only distribute the ones that actually are conjugates. Leave the other undistributed. That'll help you in the long run. So we take the top and we FOIL it out. The square root of 2 plus x times the square root of 2 plus x is just 2 plus x. Now with conjugates, what happens to that outer and inner? What happens to them? They always go to 0. So I'm not even going to write them down. We have positive square root of 2, square root of 2 plus x, minus square root of 2, square root of 2 plus x. And those are exact opposites and they cancel to 0. And then last times last, we have negative square root of 2 times positive square root of 2, which is just negative 2. All over. Leave these guys undistributed. We don't want to distribute the x because I'm hoping to cancel it later. So on top, 2 minus 2 is 0, and that just leaves me with x over x square root of 2 plus x plus the square root of 2. And then finally, we can cancel those x's. An x on top and an x on bottom will simplify to leave me with what new function? 1 over the square root of 2 plus x plus the square root of 2. So there's my new function. At this point, I can resubstitute. Do we need to pause for a second? Everyone's okay? Okay. I can resubstitute the 0, and I get 1 over the square root of 2 plus the square root of 2. And what is the square root of 2 plus the square root of 2? 2 square roots of 2, right? Right? That's how we add radicals. We add the numbers in front. So we have 1 over 2 square roots of 2. And I'll give you a little tip here. In calculus, we don't make you rationalize denominators anymore. I know, you're so excited, aren't you? But sometimes your book does anyway, so be careful, but I don't make you. The square root in the denominator doesn't bother me at all. But if I did rationalize that, that would give me the square root of 2 over 4? Yeah. So either of those answers is acceptable. For this example, we're looking at the limit as x approaches 0 of 1 over x plus 4 minus 1 over 4 all over x. What happens if we plug 0 in?
Indeterminate.
We get indeterminate form, right? We get 1/4 minus 1/4 over 0, which is 0 over 0. Now notice 0 over 0 is different than a number over 0. A number over 0 is indicative of a vertical asymptote. 0 over 0 usually means there's a hole there, although it could be a jump or an oscillation. So we have to be very careful. But if it's a hole, we will be able to algebraically remove it. So let's take a look. What's wrong with this function right here?
Just have
It's a
to be
fraction of
It has a fraction inside of a fraction. We call that a complex fraction. And I taught you guys in algebra that there's a really quick way to rid yourselves of complex fractions. That is to take the common denominator of all of the terms. This one, and this one. Remember that this guy's denominator is 1. And multiply the top and bottom by it. So it's the same as multiplying by 1. So what's our common denominator? 4 times x plus 4. So we're going to multiply by 4 times x plus 4, 4 times x plus 4, and on bottom as well, 4 times x plus 4. We're going to simplify what we can. The x plus 4 here reduces to 1, and I'm left with 4 times 1. In this fraction, the 4 is reduced, and I'm left with negative 1 times x plus 4. And on the bottom, nothing reduces, so I'm left with an x, a 4, and an x plus 4. What do I need to cancel here? I need an x to cancel. Yeah, so somehow from the top and bottom, I need to be able to cancel an x. Let's see what happens on top when I distribute this minus sign here. Like this is 4 minus x minus 4 all over 4 times x plus 4. So the 4's make 0, and I'm left with negative x over 4x, x plus 4. And look at that. What happens to the x's? They're gone. They cancel. So my new function is negative 1 over 4x plus 4. We'll talk back through it in just a second. So there's my new function. Now we just reapply the limit as x approaches 0. And if we resubstitute here, we get negative 1 over 4 times 4. So it looks like our limit is negative 1/16. We're going to pause and talk back through it again. For our last algebraic example, we have the limit as delta x approaches 0 of x plus delta x quantity squared minus x squared all over delta x. A lot of books use h instead of delta x, so you may recognize this as it's like the difference quotient, but it's already been substituted into. So I just want to make sure that you're comfortable working with this. Do you guys want to... Okay, so a lot of books use delta x, but we're just going to replace them with h's. Is that okay with you guys? And you're welcome to do that. Anytime you see a delta x, just use an h instead. They're used interchangeably. Okay? All right. So let's look at the limit as h approaches 0 of x plus h squared minus x squared all over h. And the first thing you'll notice here is that you have two variables. One of them we're letting go to 0. Which one? H. So if we substitute 0 for h, what do I get?
A number
I get x squared minus x squared over 0. So that's indeterminate form. Agree? Okay. And what we're going to do to remove that whole is the same thing we did when we were working on instantaneous speed. Okay? We're just going to FOIL it out, factor and cancel an h, and clean it up. So that's what we're aiming for here. This right here, h minus 0, that h needs to cancel so that I can remove that whole. So we're going to square double square. And just play around with it algebraically. We see that the x squareds cancel. And once the x squareds cancel, I can take out an h on top, and I will be left with 2x plus h all over h. And then finally, this is the part where we remove the whole. We can see that h over h cancels, and that whole is effectively removed. And that leaves us with the limit as h approaches 0 of the new function, 2x plus h. And now what? Resubstitute the 0. Yeah.
You get
2x. So it is okay to have variables in your limits if you started with multiple variables. Does that make sense to you guys?
Yeah.
Most of the time we get numbers, but if you start with multiple variables in these h situations, you'll usually, not always, but usually still have a variable left. So that's the first variable limit we've seen.